This is Euclid Book 11, definitions 18 through 20. As you can see here, I know you probably see my foot right about now, but anyway, as you can see here, this is my compass right here. This is going to be my straight edge. I know it's a ruler, but we're going to use it as a straight edge. And you can see I got two markers here. We're going to have one red and one blue, and you're going to see the reason why in a little bit. But anyway, let's start using. You can see how big this compass is. Alright, now I'm going to show you. Now you say, well, you just did this video not too long ago. Well, I have to redo it because I did it wrong. Now, the drawing wasn't wrong, but what I said about it was wrong. So that's why we're redoing this. Okay, so first thing we're going to do is we're going to uncap the blue pen. Alright, now we're going to make this circle. Now, it's kind of hard to see, but we're going to make this circle approximately 3 inches in width. And the reason I'm going to use this blue marker instead of the other one like I did in the previous video, and of course that video now is deleted, but the reason we're going to do this is because this is a smaller marker and the tip is smaller, and thus it should make my drawing a little bit easier to make. Now, granted, this will not be perfect in any way, shape, or form, but there you go. Okay. Now, the next step is to draw the diameter of this circle, and I'm hoping this will be done right this time. I tried to do this once and it didn't work out so good. Yep, this is going to be just about right. The diameter, I know this is not going to be exactly 6 inches, but it's close enough. And nothing on this drawing is going to be exact. I'm going to tell you that right now, but it's going to be close. Anyway, let me get another blue marker here. I have a spare blue marker. There we go. That way we kind of fix this right here. Now the next step after we draw this, okay, is we've got to draw 2 tangent lines. Now that sounds pretty easy, right? Not so much. Tangent lines are not easy to draw because they literally have to cross one point and only one point. And we're going to do the best we can to get this across exactly one point. Alright, now the other one, going to have to do this kind of the same way. Like I say, I'm going to say this again, this is not going to be a perfect drawing. I'm not doing too bad. And then we have to draw, and I'm going to erase this part of it, because once it touches the circle, we don't need the extra part right here. That we don't need. Okay. I know, I kind of messed this up. Alright, now the final line we have to draw is from the center of the circle. It's going to be approximately right here. Well, now we have to draw a straight line, or as straight as this is going to be, from here to here. And if we do, we're going to form 2 right triangles. This one right here and this one right here. Now what are we doing in this particular video? Well, what we're going to do, and bear with me as I continue doing all my wonderful stuff here. La-di-dee, la-di-da. Don't you just love it being here with me tonight? Yeah. Anyway. Put these right in here like that. Perfect. Okay. Now then. Let's go ahead and let's read the definition. The definition says, when one side of those about the right triangle and a right angle triangle remaining fixed, so this would be the one side remaining fixed, the triangle is carried around and restored again to the same position from which it began to be moved. In other words, you're going to flip this triangle all the way around and all the way back around, because this would be three-dimensional if it was really the cone that it needs to be. So, you know, you're kind of getting an idea here. And if you flip that right triangle all the way around the circle and back, then the figure would be called a cone. Okay? And if the straight line which remains fixed be equal to the remaining side about the right angle which is carried around, the cone will be right angled, if less obtuse angled, and if greater acute angled. Okay, now the straight line remaining fixed, that'd be this one right here. And I would presume that it's this line right here. If this line is equal to this line, then it's right angled. If it's not, it's obtuse. If it's, you get the idea. Now, what is the axis of the cone? This is where I made my mistake. This is the axis right here. Okay? And it says the axis of the cone is the straight line which remains fixed and about which the triangle is turned. So the triangle, this whole triangle from here to here to here is turned around this line. Okay? The whole triangle is turned around this line. It goes round and round and round and round. All the way until it goes all the way around the circle. Okay? Now the final definition is, and the base is the circle described by the straight line which is carried around. Okay. Now, this is the straight line that's carried around. Okay, and it goes around, 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 all the way around the circle. So this circle is the base. This is the axis. This circle's the base. And now you have the definition of a cone. Alright, so next time you eat an ice cream cone, there you go. Alright, I will tell you more in a future video, so I want you to stay tuned.